1942. Richmond, California. The air above the shoreline shimmered with heat and salt, and the metallic tang of fresh-cut steel. You step into the yard as if into another planet. The ground trembles under the feet of 100 riveters and welders. A dozen gantry cranes trace slow, giant arcs against a bruised sky. Sparks shower like man-made lightning where men crouch over seams and weld them shut. The clang and thump are constant. Hammers on supports, the staccato of pneumatic drills, the distant roar of a test engine. Men in wool caps and leather aprons shout across the hiss of compressed air. A foreman waves a gloved fist to marshal a load of prefabricated sections being hauled by a diesel tug. A smell of oil and hot metal mixes with the cold that rides off the bay. At the center of it all moves a man with no uniform, no rank, but a presence that cuts through the noise. Henry J. Kaiser, a civilian industrialist, hard-faced, cigar stub clenched between his teeth, walks the line in a plain overcoat. He does not wear a hard hat at first. His head is bare to whatever the elements will do to it. He speaks with foremen, with riveters, with young apprentices who swivel wide-eyed from their torches. His face is lined, but his eyes are quick. Around him, problems that had seemed permanent shift into possibilities. Before Kaiser's factories took over, a Liberty ship was a slow, deliberate thing. Keeled to launch, the normal cadence of shipbuilding in 1940 was measured in months, sometimes 9 or 10. For some yards, it had been 230 days. The old yard rules had men building hull plates around frames, riveting seams by hand, fitting everything where it happened to fall. Materials arrived in bundles, not modules. The ship moved through craftsmen's hands like a procession, not like a product line. Kaiser carried a different vocabulary: assembly, standardization, throughput. He had watched shipyards and munitions plants, auto plants and housing tracts. He carried pamphlets with diagrams and time studies in his pocket. He had run massive construction projects in peacetime and had made a career of shrinking gargantuan tasks into a schedule. Here, in the yard winds, he kept repeating one sentence in a voice like a saw. If a ship is a product, build it like one. The men around him are skeptical. Old shipwrights spit on the ground and say welding is risky. Rivets have always held hulls together. Foremen mutter about brittle fractures and unforeseen stresses. Yet there's an urgency in the yard that changes the tone of argument. Convoys are being sunk in the Atlantic. Tonnage is disappearing faster than it is being replaced. And the Navy's need is not for boutique liners, but for numbers. Steel boxes loaded with munitions, tanks, food. The War Department needs fleets of identical, replaceable hulls. The problem is not theories, it is time. Kaiser's trick, the one that looks like a conjurer's move at first glance, is not a single machine or a single patent. It is a method, and methods are contagious. He brings prefabrication. Entire sections, bow blocks, stern blocks, midsections with decking and pre-installed piping are manufactured in parallel on separate assembly benches, like the way automotive frames are welded in stages. Parts that used to wait their turn at the shipwright's bench are made simultaneously in modular kits. The yard becomes less a place where ships grow from the keel up and more a factory floor where pre-made pieces are slotted together by cranes. Around a temporary office trailer, Kaiser pins up blueprints that look like subway maps, color-coded modules, stamped dimensions, weld schedules. He assigns numbers to sections, to welders, to crane teams. He brings in supervisors from his previous construction projects, men used to scheduling concrete pours and laying pipe in strict sequences. They set up shift rotations and, where possible, overlapping teams so that as one group finishes a module, another immediately picks up the next. The trick has a second, quieter component: people. Kaiser has no shortage of managers, but he needs a workforce that can learn fast. The yard becomes a school. Women, literally thousands of Rosies, are trained on shop presses and riveting machines. Local auto workers and even desert camp mechanics find themselves taught in days how to lay out a bulkhead or read a jig. Instruction is stripped down to essentials: what to measure, where to tack, and when to call the shift inspector. Mistakes are cataloged on clipboards in a room of bright lights. The same room holds a notice board where successes are pasted like trophies. Third is welding. Arc welding replaces the older rivet-heavy techniques in many places. Welding is faster and, when done correctly, requires fewer man-hours. The new welders work long, stiff hours, and the seam test stations, where inspectors hammer and flex samples, sit like stern judges at the yard's edge. Older engineers worry about cracking. Naval architects test and retest stress points. But as methods improve, preheating for critical joints, controlled cooling, and improved electrode chemistry, welds become dependable. On the first day of the new schedule, a block marked C-17 is lifted and fitted into the frame that's been waiting, a single, seamless motion that would have once taken weeks. The crane operator watches a radio feed and listens to a foreman call tolerances. Bolts are torqued to a number. Welds are checked with calipers. Pipes are slid into pre-cut channels that match like puzzle pieces. There's a rhythm, and it's musical. 100 people doing tiny things so the whole is ready when the crane places the final module. For a short, furious moment, it looks like hubris, treating ships like assembly line toys. But then the first of the prefabricated Liberty hulls slides out of its cradle and into water with an indifferent splash. It is not beautiful. It is blunt and boxy, and it is exactly what the Navy ordered. Yet the scope of the transformation is not simply speed. It is predictability. Under Kaiser's procedures, estimates that once wandered are suddenly bounded. Where a yard once promised a ship in months, they can now promise weeks. Where they had once delivered a single hull every 230 days in some places, they begin to sketch schedules that look like production charts. One ship down the ways every 4 days, on a rolling basis, not by miracle, but by method. Kaiser knows the propaganda value of a stunt. He will stage a record-built ship later, a publicity triumph to prove the point. But the real change is quieter and incremental. 100 small improvements added until the impossible becomes routine. On this cold day, the first module is slotted into place, and a foreman with grease darkening his knuckles slaps a palm against the steel and grins. The yard's tempo shifts. Men exchange looks that were once skepticism, and now are something like belief.
March 16, 1943. The Richmond shipyard is alive before sunrise. Floodlights pour across the dry dock like theater lamps on a stage. Steam hisses from vent pipes, cranes rumble on their tracks, and men in overalls and women in headscarves move through the organized chaos with the same calm urgency of a pit crew. The air smells of ozone and sea salt, of burnt metal and coffee from tin mugs. They're about to do something that no navy, no shipyard, no empire in history has managed: to assemble an entire ocean-going cargo ship in a handful of days. Henry Kaiser stands on a catwalk above the hull section marked SS Robert E. Peary. Below him, teams are already at work welding prefabricated blocks, 250 major units, thousands of smaller parts, into position. Every piece has been pre-made, pre-drilled, pre-fitted. All that remains is to connect them. The clock starts at 12:01 a.m. Torches flare to life. Sparks arc like orange rain across the scaffolds. The clang of hammers and the rasp of grinders fill the night. It's a symphony of human effort. Every man and woman part of a coordinated rhythm. Welders sealing seams, pipe fitters aligning valves, electricians threading bundles of insulated wire through labeled conduits. Above the din, loudspeakers crackle. Section 14 ready for lift. Crane 3 clear to move. The voice belongs to a young engineer named Charles Schwager, barely 30, a production supervisor who helped Kaiser map the yard's flowchart on paper, a tangle of arrows and boxes now translated into motion. On a clipboard, Schwager marks every completed module with a single red line. By noon of the first day, the lines fill the page like veins. In the traditional shipyards back east, that much progress would take weeks. Here, it's routine. By the second night, the Peary already has its bow plates sealed, its bulkhead set. Riveters, mostly women, move in teams of 4, each one stepping up as the other steps down, keeping the tempo unbroken. At the stern, a black-haired welder named Emma Riley, formerly a schoolteacher, braces herself against the wind as she traces a glowing seam across a joint. The arc light catches the edge of her goggles, and for a second the entire hull seems alive, pulsing with heat, with purpose. Supervisors in khaki coats check gauges and timers. The yard never sleeps. The cafeteria stays open 24 hours, and coffee is dispensed by the gallon. If you stand at the edge of the dock in those hours between midnight and dawn, you can feel the vibration through the soles of your boots, a living pulse of steelwork and determination. By day 3, the Peary's shape is complete. Crews swarm the deck, fitting hatches, securing winches, running electrical lines. The ship's name is already stenciled in black letters along the bow, though she hasn't yet touched water. Newsmen arrive with cameras and notebooks. The Navy's Bureau of Ships sends inspectors who watch, disbelieving, as welding arcs flash faster than they can count. "Impossible," one of them mutters, not in disbelief now, but awe. Henry Kaiser himself barely pauses to sleep. His overcoat is streaked with grime. His cigar burns down to a stub. "The war can't wait," he says, when a journalist shouts a question about the pace. "So neither can we." Then comes the moment of truth. 4 days and 15 hours after the first weld was struck, the Robert E. Peary is ready for launch. A band assembles on the pier, brass gleaming, uniforms crisp. Workers, families, and officers line the yard, their faces tired but glowing. Reporters scribble the figure: 4 days, 15 hours, and 29 minutes, from keel to launch. A woman steps forward with the bottle, Mrs. Peary, the sponsor. She raises it high and shouts above the cheering, "I christen thee, Robert E. Peary." The bottle shatters, the hull slides forward with a deep, thunderous groan as the blocks give way, and the ship takes the water, nose first, then flat. A geyser of white spray rises into the air, sparkling in the California sun. People weep, men throw their caps, someone starts singing "Anchors Aweigh." For a moment the entire yard stands still, watching as the Peary floats, alive, real, solid steel made by human hands in a fraction of the time anyone thought possible. Across the Atlantic, British newspapers will call it the Liberty Miracle. In Washington, a general will send a telegram reading simply, "Keep them coming." But in the yard, as the sound of cheering fades away, Kaiser just looks down at the still wet hull and says quietly to his engineers, "Now, let's make the next one easier." Because this was never about a stunt. It was proof of concept, proof that industrial miracles could be scheduled, taught, and repeated. And within months they would be, until the 4-day ship was not a headline, but a production goal. In shipyards from Portland to Baltimore, Kaiser's method spreads like gospel. Prefabrication, modular assembly, continuous flow, the civilian vocabulary of a man who never went to sea, but changed how ships were built. By war's end, 2,710 Liberty ships will be launched, one every few days. The oceans will fill with their gray silhouettes, carrying food, tanks, fuel, and hope to every front. Each one owes its existence to that impossible trick, not a miracle of luck, but of logistics. And it began here, on a cold March morning, when a man in a rumpled overcoat proved
By
that
summer
time itself could
1943,
be
the
engineered.
Richmond shipyard is no longer a curiosity. It's a symbol. Its pace has become the measure of America's industrial heartbeat. But behind the headlines and the cheering crowds stands another figure, a quiet, meticulous mind whose contribution to the impossible trick is rarely told. His name is Donald Douglas Sr., a naval architect turned civilian engineer and one of Kaiser's earliest hires. While Kaiser brought the vision, Douglas brought the math. It was Douglas who first studied how airplane factories used flow manufacturing to eliminate idle time between stations. In 1941, while others still saw ships as hand-built works of craftsmanship, Douglas sketched diagrams that showed hulls divided into numbered sections, each small enough to be fabricated separately and then joined. It was Douglas who said, "If we can build a bomber in a week, why not a ship?" Kaiser listened, and that is perhaps the real miracle, that an industrialist who built dams and highways trusted a handful of engineers to reinvent an art form older than the Republic. Inside the design shed, amid chalkboards scrawled with angles and tolerances, Douglas and his team refined the sequence system. Each part, from a bulkhead plate to a porthole frame, was assigned a code and a fabrication path. Sub-assemblies were made in different shops, color-coded by stage, and trucked to the main slipway according to a schedule written down to the hour. It wasn't glamorous, but it worked. What made it revolutionary was the discipline behind it: standardization. Every Liberty ship used the same hull design: 441 feet long, 57 feet wide, 5 cargo holds, triple expansion steam engine, so every part could be interchanged. Bolts, brackets, and beams were manufactured in the thousands. A part made in Oregon could fit perfectly in a hull being welded in Maine. That uniformity turned 1,000 yards into one collective machine. Even the smallest details were calculated. Douglas's team analyzed how workers moved between tasks. They shortened the distance between tool benches and materials. They rotated crews to prevent fatigue. They even redesigned scaffolds so welders could reach seams without bending at the waist, shaving seconds off each motion. It wasn't flashy, but across thousands of welds, seconds became hours. Hours became days. The result? The 4-day ship was no longer a one-time feat. It became a rhythm. At its peak, the Richmond Complex, yards 1 through 4, launched 3 Liberty ships a week, employing over 90,000 workers, many of them women, many of them migrants from across the country. Posters read, "Your work here wins battles out there." Every ship bore a name honoring American heroes, from scientists to abolitionists: Booker T. Washington, Harriet Tubman, Patrick Henry. Each hull carried not just cargo, but a piece of American identity, welded together by hands that had never touched a ship before. The work was brutal, the hours long. Accidents were common, yet morale stayed high, because every launch meant something tangible, something that would sail that very week to feed troops, to reinforce allies, to strike back. In one of the few surviving memos from Kaiser's office, there's a handwritten note scrawled in the margin. "People don't build ships, systems do. People build systems." That was the secret, and the reason the world would remember the Liberty Fleet not just as a triumph of speed, but as a revolution in thinking. The irony was that Kaiser himself had never built a ship before 1941. He wasn't bound by tradition, which made him dangerous. He treated the shipyard like an experiment, and the experiment worked so spectacularly that it rewrote how nations measure industrial power. And yet, Kaiser never let the spotlight linger. When reporters asked him how he had achieved it, he shrugged. "We took the impossible and broke it into parts." That humility was part truth, part strategy. Behind the slogan was a ruthless efficiency. Charts, time cards, and process logs that mapped every minute of every shift. Supervisors were trained to detect bottlenecks and fix them before they rippled downstream. Each section chief reported twice per shift to a central dispatch office, where the entire yard's progress was tracked on a massive wall chart, a living graph of America's war machine. Even President Roosevelt noticed. On a tour of the shipyard in late 1943, FDR, wrapped in his Navy cape, looked out over the forest of cranes and asked Kaiser, "How fast can you make me a fleet?" Kaiser smiled. "As fast as you need it, sir." That wasn't bravado. It was a statement of fact. Because by then, the impossible had already been done. But every miracle in wartime comes with a price, and the next chapter of the Liberty Ship story would test just how far America's speed at all costs philosophy could go before it cracked, literally,
Winter,
at the seams.
1943. The North Atlantic roars gray and merciless. In the distance, through sleet and foam, a Liberty ship creaks and shudders her way through waves that rise higher than her bridge. Her name is SS John P. Gaines, one of the hundreds that had slid down the ways in the feverish rush of the Kaiser miracle. Her steel hull groans under the strain. Each swell slams into her bow like a hammer, sending a tremor down her welded seams. The men aboard, young merchant mariners, some barely out of high school, huddle near the boiler room, hands wrapped around mugs of coffee done cold. Somewhere in the darkness, the hull makes a sound no sailor wants to hear. A sharp, splitting crack. Within seconds, the ship's deck plates twist, the midsection buckles, and in the freezing water of the Aleutians, the Gaines snaps in half. The Liberty Fleet, America's symbol of unstoppable output, has just met the limits of its own success. News of the disaster reaches Washington within hours. The Navy's Bureau of Ships sends engineers racing to investigate. In a conference room filled with blueprints and metallurgical samples, the verdict is stark: brittle fracture. The welded seams, once the miracle that made Liberty ships so quick to build, were now suspected of turning lethal in cold waters. Unlike riveted joints, which could flex and absorb shock, welded steel in sub-zero temperatures could crack like glass. It wasn't sabotage or poor workmanship. It was physics. The wartime steel being produced in such massive quantities contained higher sulfur and phosphorus content than ideal. Combined with the rigid welds and the stress of Arctic convoys, it created the perfect conditions for catastrophic failure. By early 1944, over 1,200 Liberty ships showed some degree of cracking. 19 had broken completely in two. To the public, these facts were whispered, never shouted. The Liberty program was too vital to morale. But inside the yards, engineers worked around the clock to diagnose the problem. One of them was a quiet, bespectacled metallurgist named Constance Tipper of Cambridge University, a civilian scientist enlisted by the British Admiralty. Her research would become famous as the Tipper test. Tipper proved what many suspected. The issue wasn't the welds alone, but the ductile to brittle transition, the point at which steel, when cold enough, no longer bends but breaks. The solution wasn't mystical. It required better alloy control, preheating weld zones, and careful design changes. The discovery was humbling. For the first time since Kaiser's revolution began, America had to pause and reconsider. The Liberty miracle had built ships faster than ever, but it had also built them on the razor edge of material science. But this was not failure, it was evolution. Kaiser's engineers took the findings seriously. They modified welding procedures, added crack arresters, small notches in stress points designed to stop a fracture from spreading, and improved quality control. The response was immediate, coordinated, and astonishingly effective. By mid-1944, Liberty ships were stronger, safer, and more reliable. The worst of the disasters had passed. Meanwhile, the war raged on. Convoys filled with Liberty ships steamed toward Normandy, North Africa, and the Pacific. These boxy, unlovely vessels, derided by some sailors as ugly ducklings, were now the lifeline of an army spread across the globe. Each Liberty could carry over 9,000 tons of cargo, enough to feed a division for a week, or to haul 1,000 jeeps or 5,000 tons of ammunition. They brought fuel to Patton's tanks, rations to Eisenhower's troops, and medical supplies to island bases no one could pronounce. They were slow, just 11 knots, but steady, dependable, and above all, replaceable. If one went down, another would leave the dock days later. Henry Kaiser, hearing of the gains and the other losses, didn't deny the risk. He said, "Every ship teaches us something. Every one we build better." That was the essence of his engineering faith, iteration, not perfection. In the cold arithmetic of total war, the Liberty ship wasn't meant to be eternal. It was meant to be enough. Strong enough to last the war, fast enough to arrive before disaster, and cheap enough that losing one didn't cripple production. And in that brutal logic lay its triumph. By 1945, the flaws had been tamed. The Liberty fleet became the backbone of Allied logistics, a floating factory line stretching from San Francisco to Southampton. When the war ended, they carried home the very soldiers they had once supplied. Some were scrapped, some repurposed, some converted into peacetime freighters. A few remain today, museum ships, silent witnesses to the industrial gamble that changed history. But for every gleaming survivor, there are hundreds that lived short, hard lives, battered by storms, scarred by torpedoes, and kept afloat by the ingenuity of welders, engineers, and a civilian with the nerve to defy tradition. In the end, the Liberty ship was never about beauty. It was about belief that ordinary people, with enough will and organization, could build the impossible. A fleet born from a trick, refined by error, and immortalized by necessity. The kind of miracle that only happens when the world is burning and time itself becomes the enemy. From 230 days to 4. From blueprint to ocean, from theory to thunder. Henry Kaiser's impossible trick didn't just change shipbuilding, it changed the very definition of what industry could do when pushed to its limits. And the Liberty ships, ugly and magnificent, carried the proof across every sea. End.